We aren't doing any math today. We'll get to that later, but let's go over the concepts of the difference between series and parallel circuits. Really, there aren't any circuits in the world almost that work the way last week's did, where it's just one battery and one thing hooked up to it. Almost nothing works that way. Maybe your flashlight, okay? So really, we want to get to something more sophisticated than that. So one example of series circuits would be Christmas lights. And I'm going to show you, I'm going to ask you to go and look for some in your house at the end of this video. But for these type of circuits, the current goes through the circuit around the loop here, okay? And the current is equal in all of the elements. On this one, it's all resistors. It's just 2 resistors, okay? But you could replace these with light bulbs or other components. So the main idea here is that the current coming from the battery must go through every single piece of the circuit to get to the other side. There are no branches. So even though sometimes when you look at this, at your first glance, you're like, well, R1 is across from R2. Doesn't that make it a parallel circuit? Okay, but no, because there aren't any branches. There's just one big loop here. So we say that this is a series circuit, and then the equivalent resistance here is given by the sum of the resistances, whatever they are. Like if this is 10 and that's 5, then you just get to add them and get 15. Okay, and then you get current by doing voltage over that sum. And then the voltages here, like if you got your voltmeter out and measured, these will be different. So unless R1 and R2 are the same, but like what we're going to discover is that the battery voltage, this is a boost, okay? This is going up in voltage, and then the voltage is going to drop when you go over the resistors. But these can be different from each other, and they add up to make the total and potential difference supplied by the battery. Okay. Then parallel circuits. These offer electrons choices of which path they want to take. So this is the most common design in circuits you're going to come across in everyday life, because this is how your house is wired, that the toaster, the blender, and the coffee pot in this picture, they are in parallel with each other. You don't have to have the toaster on to have the blender on. So this is a kind of a weird situation with the math going on here, but the current does add, and then the voltage is the same for every element. So for picture-wise, sometimes it's drawn, like your book draws it like battery, and then everything's like connected like across the same wires, like that. Sometimes it's drawn a little differently. Let me see the other version. So it's like, oops, sorry, I went too fast. So then sometimes it's drawn like this. This was super clear that these two, you've got an option. If you're an electron right here, actually you'd be coming from this side, then you can go path number 1 or path number 2. You cannot go both ways. Okay, and so what's interesting about this one is that overall, the resistance goes down the more stuff you turn on. Like the more branches you add, if I add another one over here, then electrons can come out and they see like more paths to get to the other side of the battery, okay? So this is like opening an extra lane in a traffic jam. If suddenly another lane opens up, then you can get more cars through, okay? Versus if the exact opposite is true in series circuits, if I go back to that slide, okay, if I add another resistor in series, that's like, oh, adding like a whole nother crash in here that cars have to slow down for. Okay, so um, then I just put this question in here. So think about this, and then you can go online and check the answer. So if you're thinking of like the stairs is the battery, okay, so you have to go up in potential energy, and then you're going to slide down, then there's a drop, you know, in every time the people go down the little parts of the giant slide. So which circuit has 3 voltage drops like in a row like that giant slide? Is it the series or the parallel? Okay, so you can go check that out by hitting escape in the PowerPoint, or you can like open the edit mode to see the answer to that.